Topic 8-1, adding and subtracting radicals. This can be referenced in our Holt textbook, Chapter 11, Section 7, starting on page 811. Okay, we've done some radical simplifying, so now we're actually going to start combining. With the first section, we're going to do adding and subtracting, and then in later sections, we'll be doing multiplying and dividing. All right, look at number 1 on our topic page. You notice that the radicals are the same. You have a square root of 7 and a square root of 7. Think of that like a like term. So if the radicals are the same, then all you're going to do is consider that your like term, and it stays in your answer as a radical of 7. Then you're only doing the combination of a 4 and a positive 5, which is not 11. Interesting. That's actually a 9. Sorry about that. Okay, so let's look at another one. You've got 8 square roots of 11 minus 2 square roots of 11. Again, think of the square root as being common to itself, to both of your terms, so it stays in your answer. Then all you're doing is combining an 8 and a negative 2 to get 6. All right, keep going. They're going to start getting a little bit more difficult because you're going to have to start simplifying. Like this one. If you'll look at the like terms, this is actually completely simplified because we cannot take a perfect square of 13. So in this one, you are combining what's underlined here, your square roots of 6's, with a 3 and a 5, which becomes 8 square roots of 6. And then this one you have to leave in your answer because you can't combine it. It has a different common radical. Think of it like that. All right, let's look at the next one. Here's one where these two are common, so they're underlined once. Get a little colorful here. So these two are your like terms. If you want to go back and kind of consider these like terms, this one and this one was a like term. And then this one and this one, you can either put 2 lines under it or use some highlighter. So this time you're just looking at the things that you can combine. But please make sure you take, this is red, 7 square roots of 3 plus 2 square roots of 2 minus 3 square roots of 2 minus square root of 3. Understand that there is a 1 when there's not one stated. Just like when you have a 1x, you usually do not put 1x, you just know there's understood to be a 1 in front of it. So you're going to make sure you take the negative sign with it when you combine this negative 1 with the common radical of a square roots of 3 with the 7. Therefore getting 6 square roots of 3. A positive 2 and a negative 3 combined give you a negative 1. Again, you don't have the 1 here. You're welcome to write it in, but it's not necessary. Okay, this one has to be simplified. This is shown simplified just the factorization of 192. But if you'll recall, when these numbers are large, to come to your calculator, I mean, it's already written out here for you, but I want to go ahead and let's move this over a little bit. I want to go ahead and show you where you can find these factors, and that is putting in y equals 192 divided by x. Then you're going to hit your second graph, which gives you your table. So we know that 1 times 192, but then you have 2 and 96. But see, 96 is going to actually factor out to more. Like 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So if you want to look at, I could go all the way down here to 6, 7, 5, 16. Here's 16. 16, oh, I'm sorry, that's not a 2. The 8 and 24. Sorry. There we go. Look at this one, 8 and 24. So if you weren't going to write it out knowing every single one of the prime factors, actually that's not a prime factor, but these are some factors, I would show it like this. 192, going to my calculator and finding what you want to try to find is a perfect square. And I see one right here. If I have 12 times 16, I know that 16 is a perfect square of 4s. Whereas 12 is 6 times 2. Well, that actually factors out to 4. Let's do the 4. 4 times 3. Here's a pair of 2s. Because you're looking for pairs, groupings. So, did I not see the 8 and the... 2, 4, 8, 8. I'm sorry, I'm looking for pairs here. Well, let's just keep it with this one. Okay, so if I look at this, I have a pair of 2s and a pair of 4s. It's done a little bit differently than this one, but we're going to end up with the same answer. So that this ends up being 2 times 4, because those are what factor, if you want to think about that, what's circled is factored completely outside of your radical, where the one I boxed, because it's not a pair, is left underneath. Don't forget what's left underneath your radical sign. So a 2 is factored out, and a 4 is factored out, and the 3 was left over, square roots of 3. This is 8 square roots of 3, but you got to be careful because there's already a 5 on the outside. This answer is only the answer for what the simplified form of square root of 192. So now you have to actually multiply this 8. Don't want to get too many busy arrows, but I was going to try to show you that that has to be multiplied with that 5. So that would be 40 square roots of 3. Notice that's where they have it written out. I like the factor tree, but if you can think of the factors this way to its prime factorization, you can do it that way too. Okay, but we're not finished because this was minus 7 square roots of 3. Well, notice there you have 2 like terms, so you actually can do the subtraction, leaving you 33 square roots of 3. So pause this, study that a little bit closer if you need to before we move on. But let's go ahead and look at the next 2 problems. Number 6 has 3 terms. One's 25 square roots of 2, 2 square roots of 27, and 3 square roots of 98. I'm going to start at the back one of this one. Let's put 98 divided by x. Get rid of that x. Go to second table. And this can't see this one very well. Let's put it over here. Maybe that you can see these numbers a little bit better. So you're looking for a perfect square. Let's see if we can find one. There we go. A pair of 7s is where they got that, because 49 times 2 is 98. So get in the habit of circling your pairs, boxing what's going to stay underneath the radical. Circling a pair, 9 times 3 is 27, but 2 3s make 27. The 3 is going to stay under the radical. So that this becomes 3 square roots of 3, but this 3 has to be multiplied by that 2, so that's 6 square roots of 3. This became 2 times 49, which is a pair of 7s, so this becomes 7 square roots of 2, but don't forget to multiply these 2 together. Maybe write the little word multiply. Here I just used a dot trying to show that we had to multiply those 2. But if you want to remember that you had to multiply what's factored in its simplified form of 98 and multiply 7 times a negative 3, and that's where we got the negative 21. Study that closely because this square root of 2 is under our box. This square root of 3 is what was boxed, so it doesn't factor completely out of the radicand. Alright, so look at what's common here. We've got 25 square roots of 2 from the original problem, plus 6 square roots of 3 because of having to multiply this, and that stayed under. And then this one combines with this one to become 4 square roots of 2. whereas 6 square roots of 3 just stays in your answer. These two, these two were able to combine. 25 minus 21 is 4. This doesn't seem real focused, if that helps. Okay, one more. This one's all completely worked out for you, but I want you to break it down and look at it closely. This is already simplified. Actually, this one's already simplified too. 6 is 2 times 3, but there's no pair to circle, so actually the 6 stays under the radical because you were not able to have a complete perfect square to factor out. 48 is 24 times 2. They actually are showing this more like the factor tree. 24 is 4 times 6. We do have a pair here because this would be 2 and 2. And then 6 is 2 and 3. So if you even show it in a factor tree, you get a set of 2's, another set of 2's. Put a box around what what will not be removed outside of the radical. 9 times 6 is 54, so you're able to have a pair of 3's with 9, but notice that's actually going to stay the 6, just like it did over here, because 2 and 3 is not a pair. So this multiplied by that, if it helps to get a little colorful with this, make sure that you multiply. This is all going to be 2 sets of 2 is 4. 4 times 2, this is 3 times a negative 6. So you got to make sure that you're multiplying what I've highlighted in pink here. So this is 4 times 2, which is 8 square roots of 3. This stays, that one's factored. This one you have to multiply by your negative 6, which is negative 18. And then remember I boxed what stays under the radical. And then we've underlined those things that were like terms. Your square root of 6's are like terms, and your square root of 3's are like terms. So combining those sets gives you that final answer, 15 square roots of 3 minus 22 square roots of 3. And that concludes 8-1.